Okay, so hi everyone. So today we're gonna continue the topic of pointer. And because pointer is such a new and I would say complicated topic, so before I start introducing today's new concept of pointer, I want to use a series of Slido quiz to test if you guys understand what we taught this Tuesday. So prepare your smartphone, we will have a series of Slido quiz. Okay. Yeah, the mic is still weird. Okay, I hope it's better right now. Okay, so the first question's here. So we have several statements here, and please choose all the correct statements about pointers in C. And the statement will need to be true, need to be the correct statement, and there are more than one correct answers. So the first one is pointer variable can store the value of variables directly. The second is pointer variables store the address of other variables. The third one is pointer variables can store only integer values. And the fourth is pointer variables have memory address. And the next one is pointer and variables have no relation to each other. The final one is a variable's pointer is the address of that variable. So based on what you learned these Tuesday, you should be able to choose all the correct statement. And let's wait until we have 40 submissions. And please don't forget to enter your student ID. We will calculate that at the end of the semester for your bonus score. Okay, we need 8 more. 3. Okay, we just need 2 more. Let's check out the results. Very good. So most of the submission choose all the 3 correct answers here. So these 3 statements are the correct answers. So the first one, yes, pointer variables store the address of other variables. And we also say that in C, the address of the variable is the pointer of the variable. These 2 things are the same in C. And finally, since pointer variables are also a variable, so it also have the memory address because we also need to allocate space in the computer memory to store the pointer variable. Very good. So let's check out the next one. So the next question is to test if you understand indirection operator. So the question is, what does the indirection operator, the asterisk, do when used with the pointer variable in C? So if we apply indirection operators on pointer variables, what will happen? And there's only one correct answer, so let's wait until we have 30 submissions. It should be quick. There's only one correct answer. Okay, we already have 32, so let's check out the result. Okay. So some of you, so I will say over a half of the submission choose the correct one. So the answer is it access the objects, the pointer variable point to. But I also noticed that a lot of people choose the second one. So the second one is for the address operators. The second one says it assigns, it's not actually the address operator, but it's related to address operator. So the second option is that it said that it assigns a new address to the pointer. But the indirection operator doesn't help us to do that. Indirection operator just help us to access the object that pointer variable point to. But to do the second one, we need to apply the address, the AND symbol operator, to another variable and then assign the return value to a pointer variable. So the second statement, the second option is totally different things. So the correct answer is the first one. And please remember what is indirection operator and address operator, because you will use a lot of indirection operator when you use pointers. So let's check out the third one. The third question is, what will be the output of this program? So this question just tests whether you can understand the effect of indirection and address operator. Again, let's wait until we have 30 submissions. Okay, we have 32. So very good. So most of you choose the correct one, over 70%. So the answer is here. At the end, the value of variable I will be 20 because we make P point to I first. And then we apply indirection operator to P. So it will make P become the object it points to. And based on the second, the line here, the second line in the main function, we can see P is pointing to I. So the third line in the main function is equal to assign 20 to I, because we can replace start P by I, the variable it points to. So the latest value stored inside variable I is 20 instead of 10. 10 is the initial value. Okay, so let's try the next one. So again, your job is to choose what is the correct output of this program. And here we have two pointers. We have two pointer variables, P1 and P2. And let's wait until we have 30 submissions. Okay, we need one more. Okay, let's check out the result. Okay. So I won't say the result's really good because around half of you choose the incorrect answer here. So the correct answer is that the value stored inside, the latest value stored inside variable x is 20. And if you choose this option, the output value is 10 equals, x equals to 10. Maybe you just forgot that. Maybe you can check out. Maybe you didn't understand this line. So what this line, assign P1 to P2, what this line will do is to make P2 point to the same object P1 is point to. Because the value stored inside P1 is here, the address of the variable x. So when we assign the value P1 stored to another pointer variable P2, we assign the address of x to pointer variable P2. So now P2 store the address of x, and this means that P2 point to x as well. So when I use the apply indirection operator to P2, it will make this expression become the object P2 is pointing to, that is x. So the line before printf is equals to, we assign 20 to x. So that is why the value of x when we use printf is 20 instead of 10. So in this case, the value of x can be changed by P1 and P2 because both P1 and P2 point to variable x. So if you still cannot understand it, I strongly recommend you to have a place to have a pen and paper and to draw the relationship between x, P1 and P2. And just like I showed you in the last slide, in this Tuesday, in the later slides, if you can draw the figures one step by one step, you can understand these questions. Okay, so that is all for the recap slide. And I will say about half of you have already understand the important concept about pointer we introduced in the last lesson. So I'm good. I'm okay with that. However, I noticed there are still some students struggle with the understanding about the pointer. So I recommend you to review the slides this Tuesday and really remember what is the concept of pointer, variables, indirection operator, and address operator. Because in the following lessons, we just assume that you guys understand all these basic things. And we will build up more things based on this basic understanding of pointers. So what we're gonna do today is that I will introduce some usage of pointers. For example, we can use pointer as argument. We can use pointers as the return value for function. And actually, pointers and array are really close in C. So we'll introduce some applications of pointers and array. And finally, we will introduce one thing called pointer arithmetic. This is one special thing we can use when we use pointers to point to an array. So let's get started. So the first topic is we can use pointer as the argument of a function code. And to introduce these topics, we need to ask, the first question we need to ask is, what are pointers good for? Because so far, pointers seems like just another version of variable. What is the point that we need to have a pointer variable to point to another variable? What can I just manipulate the variable, the pointer variable point to? So actually there are a lot of advantage of using pointers, and pointers as argument is one of them. So let's check out the example here. So when we introduce function in previous weeks, we introduced this decompose function, right? When we introduce this decompose function, we say that we try to use this function to modify, to change its argument. Because what this decompose function wants to do is to divide the integer part of the parameter x and the fractional part of the value stored in the parameter x. So that is the goal of the decompose function. But when we introduced decompose function in the previous lesson, we say that for the function, we cannot change the argument. We cannot modify the argument we pass in the function code so that we cannot store the integer part and the fractional parts back through parameters. However, after learning the concept of pointers, we know that we can actually achieve that by modifying the decompose function like this. So what we modify here? So the thing we modify is that we change the two parameters here. Originally, the two parameters are just ordinary long and double, long integer and double parameters. But now I make it as a pointers to a long integer object and the pointer variable point to a double object. So that is said that we just what we can do is we can pass pointers to a variable to the function instead of the value of the variable itself. And if we do that, the decompose function can modify the argument, because what we pass is not the value of the argument. What we pass is the address of the argument. So I have a more detailed explanation in the following slide, so don't worry about that. So first, let's check out the function prototype of these decomposed functions. Just as mentioned in the previous slide, we declare pointer variable as its parameters. We have two pointer variable here. And then let's check out what happens if we have the function code like this. So this is the declaration and definition of the decomposed function, and let's assume that this is the function code happen in the main function. And in this function code, the first argument is the pi value here. So this value will be copied and passed to the first parameter x. And then the following two arguments are I and d. And let's assume that I is a long integer variable, d is a double variable. And what we pass here is that because the definition of the function say that the last two parameters need to be a pointer variable, need to be a pointer, right? So what kind of the value can be assigned to the pointer variables? That is the address, right? So what we need to pass to the decompose function is the address of I and the address of d. So that is why we can apply the address operator to I and d, so that the return value of I and d is the address of these two variables, so we can assign them into the corresponding pointer variable, that is int part and the flag part. And after we call the decompose functions, the relationship between I, d, x, int part, and flag part will look like this. Because the address of I is assigned to int part, so int part will point to the variable I. And because the address of d is assigned to the flag part, so the flag part will point to the variable d. So that is why the relationship look like this. That is why this figure look like this. And like we said, the value of pi 3.14159 is assigned to x. So that is why inside x is stored this value here. So let's check out what happens if we run the first line. So there's only two statements in this decompose function. So after we evaluate the first statement, what happens is that in this statement, we want to assign the one value to the start int part. So what happened here is that the first assignment want to convert the value of x into the type long. So that is why we have the cast here. And we want to assign this converted value to where int part is point to. Because we apply the indirection operator here. So where int part is point to? Based on the figure here, int part is point to the variable I. So what the first statement will do is to assign this value to the variable I. And we know that the value of x is like this. And if we convert this floating point value into type long int, it will just remove all the fractional part, only keep the integer part. So that is why the value stored inside I after the first statement is 3. By doing this, we can successfully get the integer part of the variable x. So that is what happened after the first statement. So we can rewrite the first statement like this. So these two statements are the same, are equal here. So let's check out the second statement. So what the second statement wants to do is to store the return value of this expression. The expression over here. This is the entire expression. We want to assign the return value of this expression to here. And we know if we see indirection operator apply on the pointer variable, we know that what we want to do is to get the object that this pointer variable point to. So what we want to do here is to assign the return value of this expression into the object that this pointer variable point to. And where flag part is point to? Based on the figure we have here, it points to D. So what happens is that we just assigned the return value of this expression to D. And what this expression want to do is that it just subtract the int part, the star int part from X. So what is stored inside the objects pointed by int part? The object pointed by int part is I, and the value stored inside I is 3. So it's 3. So we can actually rewrite this statement like this. So what happened here is that we just subtract the value stored inside I from X and store the outcomes to the variable D. So that is why inside the variable D, the value is the fractional part of the value X. So by doing this, we can successfully divide the integer part of X from its fractional part. So the fractional part here means the value after the decimal point. So you can see how if we pass the address of the argument to the function, we can actually change the value of the argument inside the function. So this is one useful usage of pointer. So so you can try to write this code by yourself after the class, and you can try to change the value we pass in here, and you can see that we successfully divide the integer part and the fractional part. And in here, we just print out the value of I and D, and we can see that the value of I and D are indeed changed by the decompose function. So after explaining this, we can see that, oh, okay, so sometimes in the function code, we can add the AND symbol, the address operator, in front of the variable, because that means that what we pass to the function is the address of the variable. And these things is kind of, maybe it's very similar for you, because we actually saw this a lot. So now maybe you will know why we need to add the AND symbol when we use scanf, because before today's course, when we use scanf, we always say that you just need to remember add the AND symbol in front of the variables when you use the scanf, and now we know why, because it just means that what we pass to the scanf is the address of the variables, not the value of variable itself. Because scanf, inside the function of scanf, it needs to change the value of the variables we put it here, right? Because scanf needs to store the input value into the variable we put it here. So to make a function to have the ability to change its argument, we need to pass the address of the argument instead of the argument itself. So that is why we need to write the scanf like this, because what scanf requires is the pointer instead of the ordinary variables. And now you know that although scanf arguments must be the pointers, but it doesn't mean that we always need to add the address operator in the scanf, because we can declare a pointer variable by ourselves. For example, in this case, we declare a pointer variable p, and p is already a pointer, right? So when I use p to point the variable I, and then when I use p with a scanf, I don't need to add the and symbol anymore, because the p itself is already a pointer variable. So that is why if we write down something like this, if we use p and we add and again, the address operator again, this line will produce compilation error. And now you know why. Because here, p is already a pointer variable. We don't need to get the address of the pointer variable again for the scanf. So that's why this is wrong. And in this case, we just need to put p here. So in this case, I just want to show you when we use scanf, we don't always need to add the address operators in the variable of the scanf. What we need to pay attention to is to know what is the type of the arguments we put inside scanf. So the reason, so this is the answer here. So answer is p is a pointer variable. And in this case, what the scanf trying to do here is to store the decimal int value, because we use %d here. So if the scanf trying to store the integer value to a pointer variable, it is wrong, because only the address this kind of number can assign to the pointer variable. Any other ordinary decimal integer value, they cannot be assigned to the pointer variable. Okay. And the other errors that a lot of people will have is that when a function requires us to pass pointer to a function, but there are a lot of times we forgot to do that. For example, in this case, this decompose function requires us to pass the pointer variables for the last two arguments, right? However, when we call the decompose function, when we forgot to add the address operator to I and D, this will have a dangerous result, because it means that we just randomly assigned any integer value to the pointer variables, and this pointer variable first cannot store integer value. Second, if it stores the integer value, you will not know what is the memory locations stored inside the int part and flag part. So if this kind of thing happens, I believe the latest compiler is smart enough to detect this. So if this kind of things happen in your code, you will get the compilation error. So remember, please make sure that you pass the correct things to the function. So that is all the things about pointer as argument. And the next thing I want to introduce is something we can use when we use pointer as argument. So that is how we can use this keyword const to protect argument. So when argument is a pointer to variable x, we normally assume that x will be modified, right? For example, if I have a function f and I pass the pointer to x as argument here, For the most of time, we just assume that, okay, this function f want to change the value of x. So that is why I pass the address of x to the function. However, it is not always true. Sometimes it is possible that this function f just need to check the value of x instead of changing it. So if it is the case, we need to protect the x address here. And before I introduce how to do that, let me introduce why sometimes we want to pass the pointer to the functions, but we don't want the function to change the object pointed by the pointers. So the first reason of using pointer is that if the variable x requires a large amount of storage, for example, if the value stored inside the variable x is pretty huge, and it just required a huge block, huge space in your computer memory. And if we just pass the value of x to a function, that means that we need to copy and pass the same large amount of storage again, just for this function call. And this is actually waste the time and space. So if you know that the value you store inside x is huge, but you really need to pass the value of x to the functions, instead of pass the value of x directly, what you can do is to pass the address of x to the function, because the address of variables always require the same amount of computer storage. So no matter how large the value x has stored, the address of x will not be changed. So we can always pass the address of x to the function without worrying about the size of the data it's stored. So that is one reason why we want to pass the pointer of the variable to the function instead of the variable itself. So let's go back here. So in this case, what we want to do is that the purpose of f is that it just want to check out the value stored inside x, but we don't want this function to change the value of x. So to do that, we can actually use this keyword const here, and this const here should be used should go in the parameter declaration here, and we need to put it before the type of the parameter. So we can put const here. So const is the abbreviation for constant. So it can tell the C compiler that we should treat this value, we should treat this value as constant. So that means that we cannot change the value of this object. So if we put const here in the parameter list of the f function, whenever we want to do this kind of statement in the f function, you will get the compilation error, because this const keyword can protect the object pointed by p to be changed in the f function. So any attempt to change the value pointed by the pointer variable p is forbidden. So that is one useful thing about constant. Okay, so the next topic I want to introduce is use pointer as return values. So the previous slide, what I introduced is how to use pointers as arguments, how we can specify that some parameters for the functions need to be the pointer variable. However, the function itself can also return a pointer. So to allow functions to return the pointer, we need to change the return type of the function. So here we have the example here. So this function is called max. And what this max function wants to do is to return the larger number, and the parameters of this max function is a and b. So the max function will compare a and b and return the value that is larger than the other one. And in this case, what I want this max function to return is a pointer point to the larger value. So to say that this function need to return the pointers, the return type need to be written down like this. So this return type is actually pretty similar with the declaration of the pointer variable we introduced in the last lessons. Because here we say that if the name of the variable is preceded by the asterisk, it means that this variable is a pointer variable. So it is also the same for the function name. So if the function name is preceded by the asterisk when we declare it, then it means that what this function will return is a pointer. And what this pointer can point to is here. So here the function this pointer can point to is an integer object. So it means that what this function will return is a pointer variable that can point to an integer object. And we can check out the return here. So the return here, we just return A or B. And A or B is also have the same type with the return type, right? Because A and B is also the pointer variable point to the integer object. We can see it in the parameter list here. So this is a correct function. And let's check out how we can use this max function and how we can get the return value of this max function. So here is how we can call the max function in the main function. So first, I just declare I and j as two integer variables, and I have another pointer p here. So p is a pointer variable that can point to the integer object. And then here I just call the max function like this. And what I want to do is to compare I and j, and then I want to store the larger value to, I want p to point to the larger value. So when I call max function, what I need to put in the arguments need to be and I and and j, because the parameter is a pointer variable a and b, and the value that can store inside the pointer variable is the address of that variable. So that is why we need to use address operator to get the address of I and j. And we need to know that the return type of max function is integer pointer, right? So we need to use an integer pointer variable to store the return value of max function. So after this code, the return value will be the address of I or the address of j. And if we assign the address of I or address of j to p, it will mean that p is point to either I variable or j variable. And I know it can be a bit complicated, but again, here I just provide you some image here, and I will encourage you to try to label the relationship between among all these variables, and you can follow the line one line by one line in the max function and in the main function here. And yeah, I just encourage you to just draw the relationship by yourself, and I believe you will have a better understanding about what happens in this max function code. And you can do that when we have the break, but before the break, the final thing I want to remind you is that when we use a function to return, sorry, I just find a typo here. Okay, so when we use a function to return pointer variable, we need to very careful about we can only return the pointer to the external function or the static local function, external variable or the static local variable. We cannot return the pointer point to the automatic local variable. For example, if we have the static local variable like the int I here, in the case on the right there, it is okay because the static local variable will still exist even we terminate the function. So this is okay. However, if this variable I is the automatic local variable, like the variable at the left example here, we cannot return the pointer of this automatic local variable. And the reason is that after we exit the function, after we return the function, this automatic local variable I will be deallocated from the computer memory. So this I will be disappear from the computer memory. So we don't have the address of I in this case. Yeah, so that is one thing we need to pay attention to when we use pointer as the return value. So let's take a break right now. And during the break, I encourage you to finish the drawing of this slide here. And please come back here after 5 minutes.